Hello, let's continue our Sudoku adventure with Vanishing Point by Riffclown. So we have irregular 6x6 Sudoku rules. So we still have rows and columns that act like normal. So in every row and every column, we are placing the digits 1 to 6 exactly once each. But instead of our normal 2x3 boxes, instead we have these bold outline regions, and they're called irregular regions or sometimes jigsaw. Because they can be any arbitrary shape as long as we still end up with 6 of them with 6 cells each. So these 6 cells are a region, these 6 cells are a region, etc. And we're still placing 1 to 6 exactly once each in each irregular region. So hopefully that's clear. Some people find it helpful to color each region so you can see where they are. Anyway, so that's just a little tip there if you want to try that. All right, so we also have Nabner lines. Nabner is Renban backwards. So they're kind of like backwards Renbans. The backwards part is not the non-repeat, though. We still cannot repeat digits on a Nabner line. So for example, normally Sudoku would allow us to put a 2 here and a 2 here. But on a Nabner line, you are not allowed to repeat digits. Now, in addition to that, no 2 digits that appear on the line are allowed to be consecutive with each other. So if I put a 2 here, I can't put a 2 here, right? Well, let's use 3 because there's a 2 in the way here. So if I put a 3 here, I can't put a 3 here because that would repeat the 3. But I also can't put a 2 or a 4, ignore the red, because 2 and 4 are on anywhere on the line because 2 and 4 are consecutive with 3. So as soon as the 3 goes on there, it removes 2, 3, and 4 from the rest of the line. So hopefully that's clear. There is a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. Okay, there's a lot going on here, but let's think about it. So this cell cannot be 4, 5, or 6 because there's a 5 on it, right? So this is only from 1, 2, 3. I think it's worth marking stuff like this. This can be 1, 2, but it can't be 3, 4, 5, but it could be 6. Let's think about 3 length lines, because we have a lot of them. So as soon as, say, a 1 goes on there, it removes the 2. And that leaves 3, 4, 5, 6. So once we place the 3... Okay, yeah, so I think the thing to think about is on a 3 length line, we're going to have 1 digit from 1, 2, 1 digit from 3, 4, and 1 digit from 5, 6. It's similar to an entropic line, but more restricted. If you remember entropic lines from a previous puzzle. So why is that? Well, let's just take one in the void. This doesn't see any givens, right? Once I put a 1 or a 2 in one of the cells, well, first of all, can I omit a 1 or a 2? That's the first thing to answer. Can this be from 3, 4, 5, 6? And the answer is no, because if I put the 2 extremes here, the 3 and the 6, well, this can't be 3, 6 because you can't repeat, but the 4 will be consecutive with the 3 and the 5 will be consecutive with the 6. There's actually, you can play around with it if you want. I don't know of like a perfect way to prove this like exhaustively without, I guess the way to see it is they're too close to each other, right? We're not gonna be able to put 3 digits that are each at least 2 away from each other, right? Because 6, 4, 2, right? Or 3, 5, 7, right? We don't have enough digits for that. So we're going to need a 1 or a 2 in one of these cells. We're not going to be able to put both 1 and 2 because they're consecutive with each other. And so that leaves 3, 4, 5, 6 for 2 cells. And as soon as now, can this be a 5, 6 pair? It cannot, right? So one of the cells will need to be 3 or 4. And then now that this is 3 or 4, that removes the other 3 and 4 from this cell, leaving only 5, 6. So we end up with 1, 2, 3, 4, 5, 6. Now, we're additionally restricted in that, say this was a 2, then this would now have to be 4, and now this would have to be 6. So if we end up with a 2 on it, then we must have a 6. It must be 2, 4, 6. If we end up with a 5 on it, it must be 1, 3, 5, because the 5 removes the 4, making that a 3, and then the 3 removes the 2, making that a 1. So those are additional restrictions. So in addition to the entropy, there's additional restrictions, but that's really interesting, which means there must be a 1 on this somewhere because there's not a 2. The 2's in the region. So yeah, very interesting stuff. So we might be able to color our lines a bit. I'm wondering where to start. Let's start with this one here. So let's say green, purple, orange. I don't know which is which. But this one of them will be 1, 2, one of them will be 3, 4, and one of them will be 5, 6. I don't know which is which though. And so what are we learning from this? Well, first of all, where does green go in this region here? This region needs a do I want it to be green to be 2 digits or 1 digit? Well, okay, so let's actually think about let's I'm sorry, I'm going all over the place because I just noticed something here. Let's make this green, but let's have green be the exact digit that this is for now. Where does this exact digit go in this region? Well, it can't repeat in the row, it can't repeat in the column, and it can't repeat on the Nabner. So if it can't repeat on any of those, then it must go here. And so it is a 4 because there's a 4 in this spot. So this ends up being 4. We'll just leave, we'll make 4 purple because no, we'll make 4 purple. I like to use purple for our middlings. Let's make 5 high, high being orange and low being blue. And we'll just go with that coloring here. This does the same thing though. So this cell can't be here in the column, can't repeat in the row, can't repeat on the Renban. So it's this 5. So this ends up being 5, which is orange. So, okay. That feels important. This cell here now can't repeat in the row and can't repeat on its Renban. So it's in one of these two, but I don't know that we can do more with that. Okay. We know there's a purple on this line and it's not 4, so it has to be the purple 3. Okay. How about the 5s affecting this region here? So this 5 looks down, this 5 looks in. It's not quite good enough, is it? Okay, let's keep thinking. So I need a 1, 2 on here, and I need a 5, 6 on here. So, okay, so 1, 2, 5, 6, but not a 5, because there's already a 4 on there, and this can't be 2. So that is actually quite restricted. Now, these are not allowed to be consecutive, so we got to be a little bit careful here. In fact, we know one of them's 5, right? In fact, yeah, we know the 6 is one of these two, because we need a 1, 2, and a 6 on here. And that means the 5 is relegated up here. So one of these is 5. So with the 5, we need a 1, 2, or 3. That can't be 2, along with the 5. Because we can't put a 4 or a 6 next to the 5. All right, I think I'm getting a handle on this puzzle, but it's taking me a little bit. Now here, there's a 5 on here. So we need to be from 1, 2, 3, 4, but it can't be 4 because 4 is consecutive with the 5, and this can't be a 2. And so there must be a 3 on here because there can't be a 4. In fact, we learned that because there's a 3 on here now, there can't be a 2. We learned a 5 on a Nabner. We learned that earlier, and I forgot to apply it. Must be 1, 3, 5. So this ends up a 1, 3 pair. The 4 doesn't restrict it as easily, but the 5 does. And so this now ends up, this 1, 3 pair means that this can't be 1. But also it means that this needs to be from 2, 4, 6. That's not a 2. Okay. So the 4 is on here because the 4 is nowhere else in the region. All right, we're making progress. I'm not sure what we can say about this cell here. We know it can't be 4 or 5. So it's from 1, 2, 3, 6. There's no 4 on this line. So there is a 3 on it. I don't know if I can do anything with that right now. It does mean this cell's not 3, but I don't know that I need to use that, so we'll hold off. All right, what haven't I thought about yet? Well, this doesn't have a 5 on it now. We didn't think about that. So that means it has a 6 on it. So it has a 1 on it and a 6 on it. So this is from 1, 3, 4, 6. This can't be 4. I mean, those are just the 4 digits left in the region, though. So maybe that's not so helpful, but we'll just leave the 1, 6 marked for now. So this can't be 1 or 6. So this is not 1, 2. It could be 3, 4. It's not 5, 6. So it's the other 3, 4 that doesn't end up on here. But we have this 1, 3 pair here telling us this can't be 3 either. So this can actually only be 4. 1 and 6 are on here. 2 and 5 are here. The 3 is already in the row. So this is 4, and then this is 1, 3, 6. Okay, nice. 4 is purple. So these two 4s look up into this region. This region needs a 4. It can only be here, which is still purple. So now here, this ends up as 6, and now we know that ends up 2, and that ends up 4. The 6 does place the 6 on here, giving us this 1, giving us the 3 and the 1, giving us this 5. Very nice. Okay, so actually I typed 8. 8 doesn't even exist. All right. We're left with this 2, 3 pair here, which doesn't seem resolved yet. This can't be 6 anymore. Let's color these. So 1s and 2s are blue. 3 is purple. So is 4. And 5 and 6 are orange. Okay, we get 2 of each color. So this row needs the orange 6. Okay, 5 looking in. Puts a 5 in one of these two, for what it's worth. We do need a 2 up here as well, because the column needs a 2. And it's not down here. This region needs a 2. Ah, yeah, so this region needs a 2. This 2 says not here, and this Nabner says this can't be 2 because there's a 1 on it. In fact, this has to be purple, so it's a 3. That gives us 2 and 3. That gives us the 3 here. So 3s are purple. We do get a deet doot in the corner for placing a 3 there. That's not a 2, so we get the 1 here. 1 is blue. And so, yeah, we were saying 2 in this box goes here, so that's blue. Now, we know we need a orange and a blue here. The blue is going to be 1 because we can't put a 2 on it, right? So there's going to be a 1 in here, and then a 5 or a 6. This is 1, 5, 6. Neither of these can be 5. This can't be 6, so it actually resolves as 1, 6. 6 is orange, 1 is blue. This can't be the 4 for the column, so this is the 4 for the column, and then this is orange 5. That means this is the purple 3, giving us the orange 6 and the purple 3. This is finished with a blue 1. This is finished with a orange 5. This finishes with a blue 2. That gives us this blue 2. This is the orange 5. All right, so this needs to be the orange 6. And then this needs to be the blue 1. And we're done. All right, cool puzzle, Riffclown. I enjoyed that. It's fun to think about how a 3-cell Nabner is actually a entropic line that's even more restricted than a normal entropic line. And yeah, nice use of the non-repeat rule for these regions. And how this ended up having to be 4 and this ended up having to be 5 because of where it goes in the region, which had a given in it. And then just general restrictions on the Nabners were neat. So cool. Hope you enjoyed this. If you did, then why not leave a like, subscribe, and a kind comment below.